Okay guys, today we're going to look at the water cycle, and you already know what the water cycle is if you think about it, because you experience it. You live in a country where it rains, so you know half of it, and you've seen puddles evaporate on hot days, you know the other half of it really. So the majority of this will be very straightforward. However, we need to talk about transpiration, which perhaps is the least obvious bit, so you might have to remember that, and you need to be able to understand really the importance of it. So this is the water cycle here. What the exam board want you to know, what the syllabus says you need to know, is you need to be able to interpret and explain the processes in diagrams of the water cycle. Basically, label it and say what happens at each point. You need to be able to explain the importance of the cycles to living things. Explain the importance of transpiration, for example, explain the importance of rain, and why the water cycle is quite an important cycle on Earth, and explain the water cycle by completing the diagram provided. So the worksheet that attaches to this, there is a diagram to label for you, and briefly describe the processes. That hits 2 of the boxes, but also I've put some questions on there relating to transpiration and also to distillation, because that looks at evaporation and condensation. So there's a bit of spiral learning in this, so you can understand sort of the context in a slightly wider context as well. So the water cycle. Well, step 1 is evaporation. Evaporation occurs because the sun is hot. The sun chucks out ridiculous amounts of energy every second, of which a lot of that is infrared, heat radiation. And that causes water to evaporate, which is a change of state from its liquid state to its gaseous state. Now, that occurs mainly in the sea. Why does it occur mainly in the sea? Because we are mainly sea. Our planet is 70% ocean. So the majority of our planet is being warmed up by the sun, is actually water being warmed up by the sun, so you get a huge amount of evaporation. So that's the first part of the water cycle, and that gas rises into the atmosphere. Stage 2 is slightly less obvious. Stage 2 is transpiration. Now, what is transpiration? Transpiration is evaporation as well, but it's evaporation in a plant. Now, transpiration is a really important part of how a plant is able to take in water. So this is to do with osmosis, the movement of water from a high concentration of water to a low concentration of water through a semi-permeable membrane, and also diffusion, the movement of water from a high concentration to a low concentration of water when it's water vapour. And transpiration is the loss of water from the leaves of a plant. The underside of the leaves have got stoma or stomata, and those are the tiny little holes that allow carbon dioxide to diffuse in, oxygen to diffuse out, but it allows water vapour to diffuse out as well. So as that is evaporating there, we've got a concentration gradient, and so diffusion will cause water to move into the leaf. That will cause, obviously, water to be taken in through the roots, because the moment I start lowering the concentration in a plant, then you've got a difference in concentration. So either it passes through the roots by osmosis, or it passes up the xylem via diffusion. So what happens is you've got water moving in through the roots, up the xylem, and then evaporating out in the leaves. All driven by diffusion. It's a passive process. It doesn't require any energy. Now, without that, plants couldn't absorb water. Without that, plants would not be able to maintain their structure, because plant structure is dependent on water. Think about a plant that hasn't been watered in a while, it tends to start to wilt. When you water it, the cells become turgid, and that gives it its stability. And that's the process of transpiration. So water goes into the sky via evaporation and transpiration. Step 3 then is what happens to that water as it rises. Well, as that water vapour rises, it cools. Why is that? Why is it colder higher up? It's closer to the sun, so it should be hotter, and warm air rises. So why is it cold in the upper atmosphere? Well, that's because the air is less dense. Air is a gas, so it will sink as low as it can because gravity will be pulling it downwards. So in the upper atmosphere, you have a very low density of air. And air is what carries heat energy. You've got convection currents of air particles moving around, oxygen molecules, nitrogen molecules, all the rest of it. And when they collide with things, that transfers heat energy. Heat effectively is kinetic energy bashing into things. So you've got less gas in the atmosphere high up, less air, so it's colder. And if you think about top of big mountains like Everest, one, it's incredibly cold, it's like -20 or -30 Celsius, but in addition to that, people have to wear breathing apparatus with oxygen masks unless they're incredibly fit, because there's so little oxygen in the atmosphere. So it gets cold higher up, there's less air to basically hold on to that heat. And as it gets cold, the water vapour condenses back from a gas to a liquid. We have condensation. And these form tiny little droplets of water. Those tiny droplets of water form clouds. So why do they float? Why don't clouds just fall out of the sky? Because they're made of water. Water's heavier than air. Well, water droplets in clouds are tiny. We're talking dust mite size, so tiny little tiny little dust particles. And because they're so light, they are able to remain buoyant. There's a constant flow of warm air upwards, so that keeps them buoyant. A good analogy for this is if you ever go into a room on a sunny day and you see the dust motes floating around, you see the dust just floating in the air. Shouldn't do, it's a solid, it should drop out, but because they're small, the air keeps it buoyant. So that's what happens to the water molecule, so the water droplets in clouds. Finally, well, clouds absorb more heat energy than the air around them. And because they absorb more heat energy from the sun, that means that they are a higher temperature, which also enables them to stay buoyant, a little bit like a hot air balloon. The air inside is hotter than the air outside, so it maintains its buoyancy. So we've got evaporation and transpiration, which chucks water vapour into the atmosphere. Then you've got condensation, as that water vapour turns back into a liquid. That makes clouds. Then we have stage 4. Now, when water droplets get big enough, they suddenly start to lose that buoyancy. They're unable then to just float in the sky anymore, and then they drop out. That's called precipitation. That could be rain, it could be sleet, it could be hail, it could be snow. But we give it a catch-all term of precipitation. In Britain, generally speaking, it's rain, but some parts of the world that could fall as sleet or snow. Okay, so we call that precipitation as a catch-all term for all of it. What happens to all that rain? Well, then it collects. Where does it collect? Well, it tends to fall on high ground. It tends to fall on mountains and areas like that, and then that water will start to collect in streams. They'll then go down to rivers, they'll then go down to lakes, and eventually back into the sea. Once you've got all that water in the sea again, the cycle is able to start all over again. Now, there's a little bit more complication in that some of that water will soak into the ground, and that's where trees and plants will be able to use it for transpiration. Some of it will collect underground. You do get underwater or underground water deposits that sort of hang around for a long time, and they may not reach their way back to the sea for a while. But that cycle is the water cycle. Okay, so first things first, you've got evaporation, which chucks the water into the atmosphere. You've got transpiration, which chucks water into the atmosphere. You've then got that water vapour condensing into a gas. That water vapour eventually precipitates, rains, sleet, snows, down to the ground, and the ground will then cause it to collect it, and then eventually feed it back to the sea. The water cycle has been going on for millions of years. Water is old. Nobody's making water molecules now. Water has been around for millions and millions of years, which means any water you've drunk today has almost certainly been through a dinosaur at some point. It's almost certainly been at the bottom of the sea at some point. So water cycle goes round and round. There is some question about where that water came from in the first place. We have some evidence that water didn't start on Earth. Water actually formed in another part of our solar system, and a giant comet or some other celestial body like that actually brought the water with it. A massive giant comet crashed into the Earth. That's where all the water came from. We have some evidence for that. So you need to know the water cycle. Some of it's really easy. You know water evaporates, so that's half of it done. Transpiration you're going to want to learn. That puts water vapour into the atmosphere. Water vapour condenses, it forms clouds. Clouds rain or precipitates, and then eventually that water washes back down streams and rivers back to the sea. That's the water cycle. So make sure you can fill in the worksheet with all that information on it. That'd be really, really good. You can explain the importance of the cycles to living things, Plants need water, we need water. Where do we get our drinking water from? Remember the potable water lesson? We get that mainly from rain. So the water cycle is crucially important to our drinking water supply. Right, I'll put this PowerPoint on Insight along with the worksheet. There were questions on the worksheet to do with transpiration and to do with distillation, which involves evaporation and condensation. So some good spiral learning questions there. Finally, in honour of a colleague of mine who no longer works with us, he used to teach this with an incredibly irritating song. I refuse to show it to you, however, the link for it is there. I warn you in advance, it is an earworm. If you want to watch it against my better judgment, feel free to. Some people find it very useful to learn the water cycle that way. Personally, it's like fingernails down the blackboard of my soul. Once you've done your worksheet, please email it to me and I will have a look at it. Otherwise, guys, take care of yourselves and I'll speak to you soon.